All right, problem number 30. In number 30, we're looking to find the surface area and the volume of this composite figure. So for this composite figure, we have a cone and a cylinder. So let's think about, first of all, the surface area, which is the first thing they're asking us. The surface area will be everything that we can see on the actual surface of this figure. So if we think about it, that is kind of like all of this outside part of the cone, just the outside part of the cylinder, and then actually the bottom of the cylinder is a different kind of surface in and of itself right down here. Okay, so we got three different things that we're going to have to figure out. First thing I'm going to work on is the outside of the cone. Now the cone surface area formula is usually pi r squared plus pi r l. Oh, and I wrote squared again. Pi r l. Now pi r squared in this formula, the surface area of the cone, represents the base. And since this cone is sitting on top of the cylinder, the base of that cone is not part of the surface of our composite figure. So really we're just looking at pi r l. And L represents slant height. Okay, so if we're doing this, we've got pi, that's still the same. R, well, the radius of the cone will be the same as the radius of the cylinder because it's sitting on top of it. So that's 5. And the slant height is the distance down the outside of the cone. So this is L. And that's actually the hypotenuse of this right triangle that the height of the cone and the radius of the cone make. So if we use the Pythagorean theorem, 5 squared plus 9 squared equals L squared, we can find out 5 squared being 25. Plus 81, that's 9 squared, 106. So L is equal to the square root of 106. Root 106. So that's the part of the cone. Next part was that cylinder. Now, the part of the surface area for the cylinder, is usually 2 pi r squareds plus pi r h. Now the 2 pi r squareds represent the bases of the cylinder, and in fact we had colored that one in blue. There's really only one base that's visible, so I'm going to say that that's pi r squared. And then the cylinder itself, the sides of the cylinder, that's that pi r h. So let's put that together. We've got pi r squared for the base, that's 25, that's 5 squared, plus pi r is still 5, and the height of the cylinder is 10. So this is 25 pi plus 50 pi, which is 75 pi. So if we put these two together for the surface area of this figure, we have the cone, we have the cylinder part and the base, which is 75 pi, plus from the cone, we have 5 root 106 pi. All right, the volume. The volume is a lot simpler than the surface area because literally we just have to take the volume of the cone plus the volume of the cylinder, and we're going to get a total volume. So the volume of the cone, the formula for that is 1/3 pi r squared h plus the volume of the cylinder is pi r squared h. Pi r squared h. And if you notice, the cone is always going to be 1/3 of the cylinder that it would perfectly fit in. This cone would not perfectly fit in this cylinder because the height of the cylinder is 10 and the height of the cone is 9, so it wouldn't perfectly fit in it. That's why we can't combine these two together. So the cone, we're going to go 1/3 pi r is 5, so 5 squared is 25, and h of that cone is 9. Plus for the cylinder, pi r squared is 25, and the h of the cylinder is 10. So if we type this into a calculator, we've got 1 divided by 3. I'm kind of ignoring the pi for a second in this first term. Times 25 times 9 gives me 75. The pi is now back, 75 pi, plus 10 times 25 is 250 pi. So if I add 250 plus 75, I'm going to get 325 pi. And that is the 325 pi. That is the volume of our composite figure.